In this video, I am going to show you how to work with inverse relations and inverse functions. I am going to show you how to find the inverse function using a 4-step procedure. I am going to show you how to verify inverses using composition, and I am going to show you how to graph inverses. Notation: the inverse of a relation R is written as R to the negative 1. So R to the negative 1 is the inverse notation for R. So to find the inverse of a relation, you would have to switch the x and the y values. One-to-one relationship. A function has a one-to-one relationship if the relation and its inverse are functions. So if the relation is a function and the inverse is also a function, then you have a one-to-one relationship. Okay, so let's take a look at the first example. So here we're given a relation. So you're given a relation. It's a set of ordered pairs. So the first set of ordered pair is 1, negative 2. And then you have 2, 4. And then you have 3, negative 1. And then you have negative 2 and then 4. So given this relation, it's a set of ordered pair, and we're going to find the inverse of this relation. So to get the inverse, okay, so to find the inverse, you would have to switch the x and the y. Here we have negative 2, comma 1. Okay, the inverse of 2, 4 is 4, 2. The inverse of 3, negative 1 is negative 1, 3. And then the inverse of negative 2, 4 is 4, negative 2. And then the next question is, so is the relation a function? Okay, so let's take a look. Now, a function is a type of rule such that when you plug in the input, you get one and only one output. So here, when you plug in 1, you get negative 2. When you plug in 2, you get 4. Plug in 3, you get negative 1. Plug in negative 2, you get 4. So the relation is a function because there is no two of the same input that produce different outputs. So this would be yes. Is the inverse a function? Okay, so let's take a look at the inverse. So here your input is negative 2, 1, 4, 2, negative 1, 3, and then 4, 2. So notice you have two of the same input. See how you have a 4 here and a 4 here. So two of the same input that produce different output. And you cannot have that in a function. So this would be no. Okay, so the inverse is not a function. And then the last question is the relation 1 to 1? Now, in order for it to be a one-to-one function, you have to have that the relation is a function and the inverse of the relation is also a function. So here we have the relation is a function, but the inverse is not a function. So therefore, we do not have a one-to-one. So the answer is no. Next, I am going to show you how to find the inverse function. So notation, the inverse of a function given f of x is written as f to the negative 1 of x. Okay, so this right here is the inverse notation. So to find the inverse of a function, first thing you do is replace f of x with y, and then you interchange x with y, so you switch the x and the y, and then you solve for y, and then the last thing you have to do is rewrite y as f to the negative 1 of x, which is the inverse notation. So let's take a look at an example. So this example is to find the inverse given that f of x is negative 2 over 5x plus 1. Okay, so we have to come up with the inverse of f of x, and we have a procedure, a process that we can use to come up with the inverse. So here, first thing we have to do is replace f of x with y. So f of x is a y, and then bring down negative 2 over 5x plus 1. Okay, so that's step 1. And then you interchange x and y. So you switch the x and the y. So here you have x is negative 2 over 5 y plus 1. Okay, that's step 2. And then step 3, we got to solve for y. So you have to get the y all by itself on one side of the equal sign. So first I would have to get rid of the positive 1, and that is to minus 1 to it, and then minus 1 to this side. So here you have x minus 1 is negative 2 over 5y. Okay, and then to get the y by itself, we have to get rid of this coefficient. Okay, so to get rid of the coefficient, you would have to multiply by the reciprocal, which is negative 5 over 2. And then you have to multiply this whole thing by negative 5 over 2. So here you have negative 2 over 5 times negative 5 over 2. That's gonna give you 1. And then 1 times y is y. And then here you distribute the negative 5 over 2 to get rid of the parenthesis. So you would end up with negative 5 over 2x and then plus 5 over 2. Okay, and then you can rewrite this as negative 5x plus 5 all over 2, because you have the same denominator. And then the last thing we have to do is replace y with the inverse notation. So the inverse, okay, is negative 5x plus 5 all over 2. Okay, so this is your inverse. Okay, let's take a look at another example. So here you have f of x is x plus 4 to the third power, and then take away 6. Okay, so we're going to find the inverse of this f of x. Okay, let's go through the 4-step procedure of how to come up with the inverse. So first thing we have to do is replace f of x with y. So the f of x becomes a y, and then x plus 4 to the third power, take away 6. Step 2 is to interchange x and y. So the y becomes an x, and then x becomes a y. Okay, so you switch it. And then step 3 is to solve for y. We have to get the y all by itself on one side of the equal sign. So here we would have to get rid of this minus 6 by adding 6 to it. And then you have to add 6 to this side. So you have x plus 6 on the left hand side of the equal sign. And then on the right hand side, you have y plus 4 to the third power. Okay, so now we have to get rid of this third power. And how do we do that? Well, we have to take cube root of it. So cube root of y plus 4 to the third power. And then you have to take cube root of x plus 6. Okay, so here we have cube root of x plus 6 is, well, the cube root takes out the cube, so you're left with y plus 4. And then the last thing you have to do to get the y all by itself is to take away the positive 4. So that is to minus 4 to it. And then I would have to minus 4 to this side. So I have cube root of x plus 6 take away 4 is y. So this right here is going to be the inverse function. Okay, so the inverse notation is f to the negative 1 of x. And then it's cube root of x plus 6 minus 4. And then this is your final answer. Let's take a look at another example. So here I have f of x is x minus 2 to the fourth power if x is greater than or equals to 2. Come up with the inverse of this f of x. Step 1 is to replace f of x with y. So f of x is y. And then here you have x minus 2 to the fourth power. And then interchange x and y. So y becomes an x becomes a y. Okay, and then we're going to solve for y. To solve for y, you would have to get rid of the fourth power. So to get rid of the fourth power, you would have to take fourth root of it. So fourth root of y minus 2 to the fourth power. And then you would have to take fourth root of x. So here you have fourth root of x is, so the fourth root takes away the fourth power. So you're left with just y minus 2. And then you would have to add 2 to get the y by itself. So plus 2 plus 2. So here you have fourth root of x plus 2 is y. So this right here is the inverse function. So using the inverse notation, f to the negative 1 of x is fourth root of x plus 2. Now your domain, your input for the inverse function, the values of x has to be greater than or equals to 0. So your input has to be greater than or equals to 0, because if you try to plug a negative number in for x and take fourth root of it, it would not be possible because you cannot take an even root of a negative number. So it's important to identify that the domain, the input of the inverse function, can only be numbers that are greater than or equals to 0. So next I'm going to show you guys how to verify inverses using compositions. Two functions, f and g, are inverses if and only if you can verify that f of g of x is x and then g of f of x is x. So these are two composition functions that you have to show in order to verify the two given functions inverses. Let's take a look at an example. Okay, so here, given f of x is 6x minus 15, and then g of x is 1 over 6x plus 5 over 2. Okay, and we want to see if f of x is the inverse of g of x, and then g of f is the inverse of f of x. So in order to do that, we need to verify these two. So the first one is f of g of x. Okay, so g of x is the inside function. G of x is the input. Okay, so you're going to take g of x, which is 1 over 6x plus 5 over 2. Okay, so that is going to be your input. And you're going to plug that into the x of the f of x. So it's going to look like this. So it's going to be 6 parenthesis 1 over 6 x plus 5 over 2 and then minus 15. So now you're going to simplify this. First thing you have to do is distribute the 6 here. So 6 times 1 over 6x and then 6 times 5 over 2. So 6 times 1 over 6x is just going to be x. Okay, and then 6 times 5 over 2 is going to be 30 over 2. And then minus 15. Okay, so you have x plus 15, take away 15. And then positive 15, take away 15 is 0. So here you're left with x. Okay, so this one is good. Okay, we just show that f of g of x is x. Then you have to do the other composition, which is the g of f of x. So with this one, f of x is the inside function. So f of x is the input. Okay, so you're going to take f of x, which is the 6x minus 15. Take that and you're going to plug it into the x of the g of x. So you're going to have 1 over 6 times f of x, which is 6x minus 15. And then plus 5 over 2. So we're going to simplify this. So first thing we need to do is distribute the 1 over 6. So you have 6 over 6. That's just going to be 6 over 6x, which is x. Take away 15 over 6. And then plus 5 over 2. Okay, 15 over 6 can be reduced to 5 over 2. So you have x minus 5 over 2 plus 5 over 2. So negative 5 over 2 plus 5 over 2 is 0. So you're left with just x. So this also came out to x. You can say the two functions are inverses. So you would say yes. And then inverses. Okay, so let's take a look at another one. Verify if two functions are inverses. So you're given f of x is 1 over 4 x cubed, take away 3, and g of x is cube root 4x take away 12. Okay, and then we have to verify if these two functions are inverses by showing f of g of x is x and g of f of x is x. F of g of x. So for this one, you're going to take the g of x, which is this, and you're going to plug that in to the x of the f of x. Okay, so it's going to look like this. 1 over 4 x and then cube. So this would be cube root of 4x minus 12. And then minus 3 at the end. Okay, now we're going to simplify it. So the cube, eliminate the cube root here. So those are gone, right? So we'll have 1, 4. Now since the cube eliminate the cube root, you're left with just 4x minus 12. And then minus 3. Okay, and then distribute the 1/4. So you get 4 over 4x, which is x. And then 1 over 4 times negative 12 is negative 3. And then bring down the other negative 3. Turns out to be x minus 6. See it? Minus 3 take away 3 is minus 6. So as you can see, okay, we did not get x. So this would be not inverses. Okay. The last thing I am going to show you is how to find inverse and then graph both functions and then verify the inverse relation on the graph. So let's take a look at an example. So this one is to find the inverse of the given function and then graph both functions and then verify the inverse relations on the graph. So here you're given f of x is negative 2 over 3x take away 4. Okay, so we're going to find the inverse of this function, and we know how to do that. Okay, so first thing we have to do to get the inverse is to replace f of x with y. So this would be y is negative 2 over 3x minus 4. Okay, and then interchange x and y. So x is negative 2 over 3y minus 4. And then solve for y. So solve for y here, I would have to add 4. Add 4. So this would be x plus 4 is negative 2 over 3y. And then I would have to multiply by the reciprocal of negative 2 over 3 to get rid of it. So that would be negative 3 over 2. And then multiply this by negative 3 over 2. Okay, so this would be negative 3 over 2x minus 12 over 2. When you multiply negative 2 over 3 with negative 3 over 2, you get 1. So you're left with just y. So the inverse is going to be negative 3 over 2x take away 6. And then y, this y right here. So this y is going to be the inverse. So we'll use the inverse notation to replace it. So this is the inverse. So then we have to graph f of x and the inverse of f of x. And then you want to verify the inverse relationship on the graph. So here's f of x. And then the inverse of f of x is, it was negative 3 over 2x minus 6. Okay, so here's a coordinate graph. I'm going to graph the f of x, okay, using the y-intercept and the slope. So the y-intercept is negative 4. So that means I'm going to go down 4. 1, 2, 3, 4 to find it. So here's negative 4. Okay, and then the slope is negative 2 over 3. So here's the slope. So that means I have to go down 2, 1, 2, from the y-intercept, and then 3 to the right. 1, 2, 3. So down 2, 3 to the right, I'm over here. Okay, so using those 2 points, I can make a straight line. Okay, so that's the graph of f of x. And then I'm going to go ahead and graph g of x now. So g of x, the y-intercept is negative 6. So it'll be over here. I can go down 3, 2 to the right, or I can go up 3, 2 to the left. It's the same. So if I go up 3, so 1, 2, 3, and then 2 to the left, 1, 2, I'll be over here. So that's the graph of the inverse function. You can tell the inverse is if they are reflected across the line y equals to x. Okay, so line y equals to x is going to be, so here it is. As you can see that the graphs are reflected across that line. So therefore, okay, these two functions are inverses.